The National Fire Protection Association has received a request for a formal interpretation of the definition of a separately derived system. The request is currently under review and evaluation by the committee responsible for NFPA 70. All future correspondence regarding this request will be posted. Once the committee has made a determination, the interpretation will be disseminated. The NFPA is a global organization that develops and publishes codes and standards for fire prevention and protection. NFPA 70 is the National Electrical Code, which provides requirements for electrical installations. This is the extent of the information available at this time. Updates and progress in the review process will be provided as they become available. Separately derived systems are an important concept within electrical engineering and the National Electrical Code (NEC). Understanding the definition is crucial for ensuring safe and compliant electrical installations. A separately derived system is an electrical source that is not electrically connected to the building's service entrance. It has its own grounding electrode system. Separately derived systems supply electrical power independently from the main utility feed. Common examples of separately derived systems include generators, transformers, and solar photovoltaic (PV) systems when configured as standalone power systems. The NEC provides specific requirements for the installation and wiring of separately derived systems to prevent electrical hazards and ensure proper grounding. These requirements address issues such as overcurrent protection, bonding, and grounding electrode conductor sizing. Grounding is a critical aspect of separately derived systems. The purpose of grounding is to provide a low impedance path for fault currents, which helps to quickly trip over current protective devices like circuit breakers and fuses, minimizing the risk of electrical shock and fire. According to the NEC, a grounding electrode system for a separately derived system must be established. This system typically includes a grounding electrode conductor that connects the system's neutral point to a grounding electrode, such as a ground rod, ground plate, or the building's metal water pipe if it meets specific criteria. Bonding is another essential requirement for separately derived systems. Bonding refers to the electrical interconnection of metallic parts to create a low impedance path for fault currents. Bonding ensures that all metal enclosures and equipment are at the same electrical potential, reducing the risk of electric shock. The NEC outlines specific bonding requirements for separately derived systems, including the sizing of bonding jumpers and the proper connection of equipment grounding conductors. Overcurrent protection is vital for protecting electrical systems and equipment from damage due to excessive current flow. Separately derived systems must have overcurrent protective devices, such as circuit breakers or fuses, to interrupt the flow of current in the event of a fault or overload. The NEC specifies the appropriate size and type of overcurrent protection for different types of separately derived systems based on their voltage and current ratings. Transformers are frequently used as separately derived systems to provide different voltage levels for various loads within a building. For example, a transformer can step down a 480 volt supply to a 208/120 volt system for powering lighting and receptacle circuits. When using a transformer as a separately derived system, it's important to follow the NEC requirements for grounding, bonding, and overcurrent protection. Generators are commonly used as backup power sources during power outages. When a generator is connected to a building's electrical system as a separately derived system, it must be installed in accordance with the NEC requirements. This includes providing a transfer switch to isolate the generator from the utility power supply and ensuring proper grounding and bonding. Solar PV systems can also be configured as separately derived systems when they operate independently from the utility grid. These standalone PV systems require their own grounding electrode system and must comply with the NEC requirements for overcurrent protection and disconnecting means. The NEC Article 250 contains comprehensive information on grounding and bonding requirements for all types of electrical systems, including separately derived systems. It outlines the rules for selecting and installing grounding electrodes, sizing grounding electrode conductors, and bonding metallic parts. Article 445 covers generators. Article 480 addresses storage batteries. Article 690 provides specific requirements for solar PV systems. When working with separately derived systems, it is crucial to consult the latest edition of the NEC and adhere to all applicable requirements. Failure to comply with the NEC can result in electrical hazards, equipment damage, and code violations. Furthermore, it's important to understand the specific requirements for each type of separately derived system, as they may vary depending on the application. The NEC is updated every 3 years to reflect advancements in technology and address emerging safety concerns. Therefore, it is essential to stay current with the latest edition of the NEC and any applicable local amendments. Local jurisdictions may have additional requirements for separately derived systems that are not covered in the NEC. It is always best to consult with local electrical inspectors or authorities having jurisdiction to ensure compliance with all applicable codes and regulations. Understanding the requirements for separately derived systems is an ongoing process that requires continuous learning and professional development. Electrical engineers, electricians, and other professionals working with electrical systems should regularly attend training courses and workshops to stay up to date on the latest codes and standards. By adhering to the NEC requirements for separately derived systems, electrical professionals can help to ensure the safety and reliability of electrical installations. This protects people and property from electrical hazards. In summary, a separately derived system is an electrical source that is not electrically connected to the building's service entrance and has its own grounding electrode system. The NEC provides specific requirements for the installation and wiring of separately derived systems to prevent electrical hazards and ensure proper grounding, bonding, and overcurrent protection. Common examples of separately derived systems include generators, transformers, and solar PV systems. It is crucial to consult the latest edition of the NEC and adhere to all applicable requirements when working with separately derived systems. The grounding electrode system for separately derived system typically includes a grounding electrode conductor that connects the system's neutral point to a grounding electrode. Bonding refers to the electrical interconnection of metallic parts to create a low impedance path for fault current. Overcurrent protective devices, such as circuit breakers or fuses, are essential for protecting electrical systems and equipment from damage due to excessive current flow. The NEC Article 250 contains comprehensive information on grounding and bonding requirements. Article 445 covers generators, Article 480 addresses storage batteries, and Article 690 provides specific requirements for solar PV systems. Staying current with the latest edition of the NEC and any applicable local amendments is essential. Local jurisdictions may have additional requirements for separately derived systems that are not covered in the NEC, so consulting with local electrical inspectors or AHJ is always recommended. Continuous learning and professional development are crucial for understanding the requirements for separately derived systems. By adhering to the NEC requirements, electrical professionals can help to ensure the safety and reliability of electrical installations. The interpretation by the NFPA will provide further clarification on the specific definition of a separately derived system, which will be valuable for electrical professionals in applying the NEC requirements. The request being reviewed by the committee responsible for NFPA 70 highlights the importance of clear and precise definitions in electrical codes and standards. Ambiguity in these definitions can lead to misinterpretations and inconsistent application of the codes, potentially compromising safety. The formal interpretation process ensures that the NEC is applied consistently and accurately across different jurisdictions and applications. The dissemination of the interpretation will provide valuable guidance to electrical professionals, helping them to better understand and apply the requirements for separately derived systems.